Hello, everyone. Today I'll be presenting on bilateral transfer asymmetry of a visual motor task in a workspace that requires midline crossing among left-handed individuals. I'll begin this presentation by explaining what bilateral transfer is. It's basically a concept or a phenomenon that occurs when a learned behavior transfers from an effector or a group of effectors to the other. The strength of transfer for some movement parameters differs across hands, and this is known as the asymmetry of transfer. And one model that seeks to explain the underlying mechanism regarding this observation, which is the dynamic dominance model. According to this model, asymmetry depends on information each arm controller can have access to. More specifically, it's been well documented that the dominant hand accesses directional information, while the non-dominant hand accesses information about final movement position. The purpose of the study was to explore how workspace requiring midline crossing would affect bilateral transfer asymmetry of a visual motor task for left-handed individuals. To answer this question, we recruited 32 left-handed healthy young adults for the study, and they were randomly assigned to one of two groups, which was the bilateral transfer group and a retention group. The retention group was used to track adaptation to the visual motor task. And for the experimental condition you see here, the letters here, RLR, which is an example, represents the hand used during baseline training and post-test respectively. So if we see an RLR, for instance, in the bilateral transfer group, it means they use the right hand for baseline training, the left hand for training, and the right hand for post-test. And the figure below shows the experimental setup. You can see on the table, we have the digitizer tablet connected to a monitor for visual feedback. And we also give them a non-inking pen for the movement for drawing on the tablet. And the tasks involve drawing a point-to-point movement with a visual feedback of a trace of the pen, which was 45 degrees rotated on the monitor. So where the movement trajectory was rotated, with a feedback, 45-degree angle rotation for visual feedback on a monitor. And we decided to use the 5% peak velocity criterion and velocity profile for movement onset and offset. And we process our data with a custom developed program in MATLAB. For that analysis, we had a 4x2 mixed design ANOVA with group as between factor and test time as within factor, which was pre to post test. We're interested especially in four main movement parameters, which was the movement time, trajectory length, which is also known as the path length, normalized jerk, which is the movement smoothness, and endpoint error. In the results, we could see that there was no bilateral transfer for path length. However, we saw some adaptation in a retention group that trained with their right hand. And for movement time, we could see that there was general adaptation for both retention groups. And also, there was bilateral transfer for the right hand, which was a non-dominant hand after training the left hand. We moved to normalized jerk, which was movement smoothness. We could see that there was also adaptation for the right hand retention groups, but there was no bilateral transfer for movement smoothness. And then for the endpoint error, we could see that there was also adaptation for both retention groups, but no bilateral transfer. One thing in particular you could see about the results was that they were generally cleanly separated. That's the red and the green line were cleanly separated from the blue and the black line. Now this shows the hand used for training for pre-test and post-test. And you can see that performance for the non-dominant hand was especially poorer compared to the dominant hand. What is the implication of this result? First of all, we could observe that all variables of movement for the non-dominant hand adapted to the visual motor task during retention. That's for the retention groups. And only bilateral transfer occurred for the timing control of movement, which was just the movement time, which shows the transfer from the dominant hand to the non-dominant hand. In contrast, trajectory control, such as path length and endpoint error, failed to show significant benefits of transfer. What is the implication of this result for the dynamic dominance model? We could see that while there was some form of asymmetry of bilateral transfer for the workspace we studied, our findings failed to conclusively support the dynamic dominance model. Thank you.